So hello everyone, welcome to our first lecture on operation amplifier. So this is divided into several segments, and this will be our part one of first lecture. And in this lecture basically we'll try to introduce the op amp. What is an op amp? Its different features and how we use this in our circuit applications. So that will be main focus. So we'll try to keep things pretty simple and easy, and so that it's easy for you to understand and get the basic concept of op amp and its applications. So we start our lecture by asking this very basic question: what is an op amp? So what is it? So basically op amp, which is a short version for operational amplifier, this is an integrated circuit. So this is a specially designed amplifier that is built in an integrated circuit, and that can amplify voltage and has an enormous gain. Basically op amp is an amplifier with an enormous gain. Not only enormous gain, it has many other desirable features that we look for in an amplifier, and that makes it very suitable for constructing circuits for many different applications. So op amp, it not only works as an amplifier, it can be used to construct circuits that can perform many different operations. It can have many different functionalities, and that's why the name operational amplifier. And it is the most widely used and extensively studied IC chip. The first op amp built or invented in 1971, so that is so long time back, almost 50 years back. But still today, the op amp remains the most widely used and extensively studied analog IC chip. This counterpart of this, the digital, that is the microcontroller, that was also invented in 1971, and till today, that is the most extensively, most widely used digital IC chip. Okay, so the op amps are fabricated in 8-pin IC, so this comes in an IC chip. IC means you understand the integrated circuit that integrates many different circuit components on one single chip. So op amp is made of actually many circuit components, many transistors, some resistors, and few capacitors. So that all integrated on one single chip. So, and it has 8 pins. It comes with 8 pins. How does it look like? So here are the diagrams for the IC chip. That's how they look. And they have 8 pins. You can see how they're numbered here, and you see there's a notch right at the front, and from this notch sometimes you'll have a dot, either a notch or a dot on the top, and that gives you an indication how you will count the pins. The number one starts here where you have the notch or the dot, and then you go downward 1 2 3 4, take U-turn. Here you will have 5, then 6 7 8, and so this is how you label the pins from the notch on the top of this chip. Okay, so let's move forward. So now we'll discuss about the pin layout and pin description of the op amp, how the pins are arranged around the IC chip, and their labeling, their description. So this diagram here is known as the pin layout for the op-amp IC chip. You can see that is the IC chip, this square, and on top of this we have this notch here, or we have the dot. We can have either notch or dot, and that gives us the indication how do we count the pin numbers. We start 1 here from the left, the top here, and then 2, 3, 4, going up 5, 6, 7, 8, and they are labeled like this. The 1 is offset null, 2 is inverting with minus sign, 3 is labeled non-inverting plus sign, 4 is powered V minus negative voltage, 5 is offset null, 6 is output, 7 is V plus powered, positive powered, 8 not connected. So that is how they are labeled, and this is what we call the pin layout, right? The different pins and they are naming their label. And what are the different functionalities of these pins? So we have two input pins, input, or you can call it input terminals, pin 2 and 3. These are the input pins. These are used to apply the voltages. So one is labeled inverting, so that we call the inverting input terminal. The other is labeled with the positive sign. It's called the non-inverting input terminal. And the pin 4, what is pin 4? Okay, you see that one output terminal. So we have two input terminals and one output terminal, that is terminal 6. Pin 6 is the output. We take the output from the op-amp through this pin, and it has two power supply pins, and one is positive power supply, the other is negative power supply. Pin 4 here, right, that is the negative power supply pin, so we apply negative voltage to this pin 4, and the pin 7 here is the positive power supply pin. We apply positive voltage at this pin 7. So op-amp usually requires two supply voltages, one positive supply and the other is the negative supply, unlike the conventional our BJT or MOSFET amplifiers, which works with just one single power supply. And then there are two pins, which pin 1 and 5, which are labeled as the offset null pin. So these two pins are used to nullify the offset voltage. Now, what is an offset voltage? You don't need to know now. We'll learn later. But for now, it's enough for you to know that pins 1 and 5 are the offset null pins. They're used to nullify the offset voltage. The last one, the pin 8, is written not connected, but it's not used in the circuit. It has no application, so it's just written not connected. So next we discuss about the circuit symbol, how it is represented in the circuit, the op-amp. So this is what we call the simplified circuit symbol, that just shows the two input terminals and the one output terminals. Okay, so we have our laser pointer activated. So you see that the two input terminals, first this is the triangle, right, that shows the basically the op-amp, the device represented by the triangle. So it has the input side, the left side is the input side, right side is the output side, and in the input side you have two inputs. One is the inverting input terminal, where the voltage is denoted by V minus. Minus doesn't mean that's negative voltage, but just the shows is applied to the inverting input terminal. That's why it has a minus sign. And the voltage at the non-inverting input terminal, here you have the plus. This indicates the voltage, the non-inverting input terminal, terminal 3, and the voltage that is applied to this non-inverting input terminal is indicated by V plus. So these are the convention, and the output is from pin 6. So this is simplified, what you call the simplified circuit symbol, which shows just the input and the output terminals. So detailed circuit symbol, that will show more on the symbol, In addition to the input and output signals, it will also show the power supplies, right? Like in this diagram here, we have this symbol for the op-amp, terminal 2 inverting input terminal, terminal 3 non-inverting input terminal, terminal 6 output. In addition to that, we are also showing the negative power supply and the positive power supply applied to the pins 4 and 7. So this is also, you see that here it's written dual power supply. That means that the op-amp using two power supplies, and this has, gives us an impression. Say dual power supply, why you are calling it dual power supply? Op-amp by its nature it will have two power supplies, so why do you have to call it dual power supply? This is because you can also have op-amp with a single power supply. It's not necessary that you should have two power supplies all the time. Sometimes, right, there are situations where you do not need the negative voltage. You don't have to apply the negative power supply, you just apply the positive power supply. So along with the dual power supply, we also can have op-amp with single power supply, as it is shown in this diagram. When you do not need the negative voltage, we simply ground the negative side of the power supply. So negative voltage here is 0, and so that is the diagram for the op-amp with single power supply. So this is all about the circuit symbol. Is pretty simple and easy to remember.